Okay. We've got one more thing to talk about today, or for this unit here, and that is the fundamental theorem and the particular solution. So you're going to hear a lot more about the general and particular solutions in the next unit as well. So it's really very simple. The general solution, why is my pen not working? The general solution will have a plus C. All right, so the general solution will have a plus C. And a lot of times you are going to get the general solution when you have indefinite integrals without boundaries. All right, so when you don't have bounds and you get an indefinite integral, that's when you're going to get the general solution.
What does that say?
Indefinite.
What's the first blank?
The first blank's going to be, whoop, hello, that's a definite. Definite integrals are when you have the boundaries and your answer will be like an actual number that tells you the area under the curve from your specific x values. All right, so definite integrals will give you the area under the curve. Indefinite integrals are going to give you some kind of general solution for finding the area under a curve. And then we have particular solutions. So particular solutions mean that you need to find C. They're not going to say find C. That's too easy. They're going to say find the particular solution of the given antiderivative and then blah, 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 blah. They're going to make it sound fancy. But what it means is we want to go backwards. So we want to integrate and then we want to figure out what C is. So we can have a particular solution, not a general form with a plus C. We want the specific formula for my function. So particular solutions, find the C. General solutions, have the plus C. Definite integrals have numbers and bounds, and they will give you the area under the curve. Is that okay? Okay, so let's do an example. So this one says, if f prime of x equals e to the x minus 2x squared, find the particular solution of f of x if f of 0 equals 4. So this guy right here is telling me that I need to figure out what C is. Find C. So I'm going to integrate e to the x minus 2x squared. What is the integral of e to the x? E to the x. What is the integral of negative 2x squared?
Negative 2x cubed over 3.
Yep. And then because this one does not have bounds, plus C. So this guy right here is the general form. All right. It's the general form because we don't know what C is. C could be anything. And so the way that we're going to find C is we're going to use the other piece of information that it gives me, right here, my initial condition, to figure out what C is. So what this is saying is that when x is 0, my y value is 4. So when I plug 0 into my function that I just found, I should get 4. So when you plug in 0 for all of the x's, that guy should equal 4. All right, what is, what is e to the 0? 1. And then all of that is going to just be 0. So you get 4 equals 1 plus C, which means that C is 3. Once you find C, you're going to take that, you're going to take your general form, and you're going to write the particular solution for your final answer. So your final answer is going to be f of x equals e to the x minus 2x cubed over 3 plus 3. Not too bad, right?
Sure.
Alrighty, let's try this next one. So once again, find the particular solution means that I need to find the C value. And I'm going to integrate. right, so I'm going to rewrite the 6 as 6x to the negative 2 so I can use power rule. I can leave the 2 over x because what is the integral of 2 over x? ln. And where's the 2 going to go? In the front. So 2 ln absolute value of x plus, what is the integral of 6x to the negative 2?
6 over x.
6 over x. So 6x to the negative 1 over negative 1. And then plus c. So I'm going to simplify this. I'm going to make 6 divided by negative 1 is negative 6. And then I'm going to move this x to the bottom of my fraction. Does that make sense? All right, so I'm just going to rewrite it. 2 ln absolute value of x minus 6 over x and then plus c. So this is my general solution, my general form. I don't know what c is. And to figure out c, I'm going to use my initial condition that it gives me. So when x is 1, my y value should be negative 7. So negative 7 is going to equal 2 ln of 1 minus 6 divided by 1 plus c. What is ln of 1? 0. So all that's going to go away. So you get negative 7 equals negative 6 plus c, which means c is negative 1, because then you would add 6. And so to write the particular solution, we are going to take our general form, we're going to take our c, we're going to squish them together and actually make an equation. F of x equals 2 ln absolute value of x minus 6 over x minus 1. Okay, I'm going to do one more. This one's a trig. And then we're going to talk about the second thing for today. All right, so it says if dy dx equals 1 minus sine x, find the particular solution of f of x if f of pi equals pi minus 2. So remember this notation here, dy dx, it's just another notation for derivative. So we're still going to integrate that, 1 minus sine x dx. What is the integral of 1? X. What's the integral of negative sine x?
Cosine x.
Plus cosine x. And then plus c. All right, so this guy right here is my general solution. So I'm going to plug in pi, and it should equal pi minus 2. So pi minus 2 should equal pi plus cosine of pi plus c. All right, what is cosine of pi?
Negative 1.
-1. All right, now what do you notice is on both sides?
Up high.
A pi, so those pi's are going to end up canceling. And then when you solve for c and you add 1, -1 is c. And then once you get your c, we can write our particular solution. Once again, you're going to use your general form, you're going to use your c value, and you're going to write the solution, which is x plus cosine of x minus 1.
You do like the 67.
If you forget to write f of x, are they going to count off?
No, I don't think so.
Until the next day.
Do what?
I understand everything until the next day.
What do you mean?
I understand everything from the last
Until they do your homework.
Oh, are you saying like you understand it, but then come tomorrow, come Monday, you won't get it?
I mean, like the
Take
next
your
day.
time
The next day, you
Take
hit
your
next
review on it.
day.
You do some problems over the weekend.
I say you
Lock in.
good. Try doing your homework.
That would also help you.
All right.
Yeah, you walk in there,
All right, so the last thing we're going to talk about, and we've done this before, so it went over pretty well in fourth period, but it's the fundamental theorem. And so the fundamental theorem can help us find specific points. So what you've seen it as actually is we did like the applications first. So do you remember the problems when it was like people are entering the store at a rate of this function, and they're started off with 100 people in the store. How many people are in the store after like 5 hours or whatever? And you had to do the accumulation of change and add the accumulation of change to your initial value, and that gave you the number of people in the store, right?
Yeah.
Same exact thing, just no words. All right, so we're just finding specific values. All right, so this is kind of just the reasoning behind it, but this is the fundamental theorem when you are integrating with bounds. you plug b into your antiderivative minus plug a into your antiderivative. If you're talking about the integrating of a derivative, what happens with your integral and your derivative? They cancel. And so then that's why it goes back to just regular f of b minus f of a. And so kind of this extension right here is how we can come up with this expression, which this guy here is saying that this is your initial value. This right here is your accumulation of change from your initial value to whatever point we're trying to figure out. So this is what we're trying to figure out. And that will actually give me a specific point. So the nice thing about these questions is it's all about the setup. And then it's a calculator question. So 90% of the time, these are calculator questions. You have to set it up, and then you'll type it in. So does that kind of make sense? You start with your initial value, you add it to your accumulation of change, and then that will give you this specific value right there. All right, so on this one, it says f prime of x equals x squared minus 2. So this is my rate, my function is changing. It gives me an initial condition, and I want to figure out what f of 3 is. And so the fast way to do this, especially if you have a calculator, is to say, okay, I know that my initial value is going to be negative 2, and I'm going to add that to the accumulation of change from what to what? 3, yes, 1 to 3. So your bounds are going to be your x values. All right, initial value, what we want to figure out. So these guys will always be your 2x values. And then you're going to put your function in here, x squared minus 2 dx. And then you can just type this whole expression in the calculator, negative 2 plus, and then you remember how to get the integral in the calculator. You hit math, and then and then you just type it all in and it figures it out for you, which will give you 8 over 3. All right, so a lot of times you'll see these kind of questions on the calculator part of your test. Because it's not so much like, can you do all that integration? It's, do you understand the fundamental theorem of calculus? And a lot of times you'll even see it with functions that you don't want to integrate. Like this would be a really nasty u sub. Even though it looks simple, your u would be x squared, your du would be 2x, and you got an extra x, and it all becomes a big problem. And so you're not meant to do this one by hand. It's meant to be done in the calculator. So you're going to take your initial value, which is negative 5. We're going to add that to the integral from 2 to 1. So initial value first, what you're trying to figure out, and your derivative function here on the inside, and then you can type it all in the calculator. So initial value, what you're trying to figure out. And then when you type all of that in, you will get negative 5.4945. Okay, so of course they're going to have multiple representations. So let's look at 72 where we have a graph. So on this graph, it tells me the area of these little sections here. All right, so this area it tells me is 4, this area is 9, this area is 2. Now what is special about this blue area?
Negative.
It's negative. How do I know it's negative?
Under.
Because it's under the x-axis. All right, so let's figure this out. So it says use the graph of the graph of f prime is shown. Use the figure and the fact that f of 3 equals 5 to find f of 0, f of 7, f of 9. All right, so this graph is the derivative, and I want to know what f of 0 is. I want to go backwards and know what the integral is. So when you're going backwards, that's when you're going to have to integrate. So I'm going to start with my initial condition 5 plus the integral from what to what? 3 to 0 of your graph here, f prime of x dx. Okay, now how can I figure out what the integral from 3 to 0 is?
Find what the value is at 3 and 0 on the graph. Or from 3 to 0 on the graph.
Negative.
It's negative. Why do I know it's... But what does the integral tell me? Area. So the integral is the area under the curve, which are these values that it gave me. Does that make sense? Now, because my integral is going backwards, my integral is going from 3 to 0, what does that make special about my number? It's negative. It makes my value negative. So when your integral goes backwards, it would be a negative 4.
Yeah.
So 5 plus negative 4, which would be just 1. Does that make sense? Okay, so the next one, same thing, 5 plus the integral from 3 to 7. So my initial condition is going to stay the same. I'm just accumulating the area to 7 now, f prime of x dx. All right, so the integral from 3 to 7, we're going forward, but since my area is underneath, still negative. So it'd be 5 minus 9, which would be negative 4. If you are going backwards and your area is below, double negative would make it positive. All right, and then the last one here, initial condition is 5, integral from 3 to 9. So we're going forward still 3 to 9. This is negative, this is positive. F prime of x dx. So 5 minus 9 plus 2, which would be negative 2. All right, so it's kind of all about accumulating the area, but adding your initial condition. All right, and so then my last example here, I think this was a former question on the free response part. It says a pizza with a temperature of 95 degrees Celsius is put into a 25 degrees Celsius room when T equals 0. The pizza's temperature is decreasing at a rate of R of T equals 6e to the negative 0.1 T degrees Celsius per minute. Estimate the pizza's temperature when T equals 5. All right, so what is my initial condition? That's what I want to figure out. 0. And what is the temperature at 0? 95. Because what am I concerned about? The pizza's temperature or the room's temperature? The pizza's. This is the room temperature, this is the pizza. So I don't actually care about the room temp. That's extra information. It might be used in like part B or C or something like that. All right, so this is my initial condition. So I'm going to start with 95 degrees. Now, normally you add the integral, but in this case, I'm actually going to subtract. Why are you subtracting? It's decreasing. Your temperature is decreasing. And if you were to add your integral and your temperature increased to like 120, hopefully you would get that answer and be like, that seems wrong. Because you're not going to go from 95 degrees to 120 degrees. That's not going to be right. And then you can reevaluate, oh, I'm probably subtracting since it's cooling down. Now, what are my bounds going to be on my integral? 0 to 5. And then in here is going to be your rate function, 6e to the negative 0.1 t plus, or not plus c, sorry, dt. Ugh, can't write dt. And then now you could type all of this in. And as with any word problem, it is a good idea to make sure you noun unit time after 5 minutes. The pizza temp is 71.391 degrees Celsius. All right, so you have your time, 5 minutes, you have your noun, pizza temp, and your units, 71.391. Sound good?
Yeah.
Okay, I have the review if any of you want it.